Welcome. All right, so I decided to pull up one of these problems because I think once we get used to certain type of problems, I throw in something that's going to be decimals and students automatically are like, like what is going on here? So remember, first of all, we're going to get through a couple, we're going to go through a couple equivalent equations. But remember, as long as I multiply something by every single term in our equation, I just produce an equivalent equation. So it's not going to be changing the answer. Just like if I said 2x equals 4, if I multiply everything by 3, I get 6x equals 12. Well, it doesn't matter what I multiply by. I'm still going to have the exact same answer where x is going to equal 2. So first of all, if I want to get rid of my decimals, I know that if I multiply by my bases of 10, I can just simply move over my decimal point. And what I really want to do is I need to move this decimal point over two values. So I'm going to multiply by 100. And I'm going to do this first just to make sure that I can see what these numbers are to make sure I analyze this correctly. So therefore, by multiplying, that means I'm pretty much moving the decimal point over two place values for each number. So therefore, I end up having 2x minus 5y equals negative 38. And then I have 3x plus 4y equals 104. All right, so now I'm dealing with a problem that's a little bit more similar, but I have to go through this extra step. Well, now we see that the best probably way to go about this would be using elimination. And to use elimination, I notice that I have to have the same coefficient. So therefore, I'm going to have to multiply by two multipliers since one of their coefficients is not part of the least common multiple of the two coefficients. So what I'm going to do is I'm going to eliminate the x. And to eliminate the x, I need to find the least common multiple between 2 and 3, which is 6. Therefore, to get this to be 6, I need to multiply by 3. And to get this to be 6, I need to multiply by 2. So I need to make sure I do that times every single one of these terms, times every one of these terms. So therefore, I get 6x minus 15y equals negative 114. And then over here, I have 6x plus 8y equals 208. OK, so now I see that, all right, well, now I can just subtract the two equations. Since these now have the same coefficient, I can now subtract the two equations. So by subtracting 6x minus 6x, I get 0x, which now eliminates the variable. Negative 15 minus 8 is going to be a negative 23y. And then equals negative 114 minus 208 is going to be negative 322. Then I divide by negative 23, divide by negative 23, and therefore I get y equals, looks like, positive 14. All right, so now that I know that 14 is my answer, now what I need to do is find the value of x. So I can plug it into either one of these equations that I'd like to. I guess I'll choose this value over here. So I have 3x plus 4y equals 104. Now I know that y equals 14, so I say 3x plus 4 times 14 equals 104. So I get 3x plus 4 times 14, 28. That's going to be 56 equals 104. Now I solve my one-step equation. So I get 3x equals 104 minus 56. That's going to be 48. Divide by 3, x equals a positive 16. Therefore, the solution to this system, even when I have my decimal points, is going to be y equals 14, y equals 6. Now, I could have gone through and plugged it back into this equation, right? And I would have got the exact same answer. But I like dealing with my integers, so I would use that one. Therefore, these two lines cross at the coordinate point 16, 14. So there you go, ladies and gentlemen. That's how you solve a system of equations when you have some decimals. Thanks.